When we were considering the problem of excise taxes and who bears what burden, we understood that it had a lot to do with responsiveness of quantity demanded to prices. Imagine the following. Suppose you were running a store. We'll put price on the vertical axis and quantity on the horizontal axis. And suppose that you had a deal where you found out at $7 per unit, you would sell 100 of these units in a day. It's a retail output, all right? You've got $7 for some product and you're selling 100 units a day. And somebody says, hey, you know what? We should have a sale. Let's put a sign on the door that says 50% off all day Thursday. And so you say, okay, I understand what that is. That's going to be $3.50. Now, suppose as a result of reducing it from $7 to $3.50, you move from the original point, which we'll call X, to this point, which we'll call Y. That's like 101 units. So as a result of dropping your price 50%, you get a 1% increase in volume. Is that possible? Sure. You could imagine a demand curve that's just pretty steep, like this. Now that's probably not a very smart move. Having a 50% off sale, when all it does is increase the traffic through your door by 1%, that's going to be pretty painful on your cash register at the end of the day. Now, alternatively, you could have had that same sale, and suppose that you sold some point Z, which we'll say is 1,000 units. Is that possible? Sure. The demand curve could be one that looks just like this, D1. That curve, which is much flatter than the steeper D0, that curve is quite possible. It's realistic. And you can see in that case, your 50% reduction in price led to a 10-fold increase in the amount of volume through your door. So if you're running a retail outlet and you're thinking about whether you're going to run ads in the newspaper for having X off on Sunday's newspaper, you got to have kind of an idea about what this looks like. Understanding this responsiveness is very important to understanding whether you should be having these types of sales or perhaps even just thinking about inching your price up a bit because very few people move away from your market. Economists have a term for this, elasticity of demand. Economists call this elasticity of demand, and elasticity of demand is the responsiveness of quantity demanded to changes in price. And we have a definition for this. That's E, which for us is elasticity, is equal to the percentage change in quantity over the percentage change in price. This is elasticity to us, okay? And what it basically says is it's thinking about the ratio of the impact on quantity for any impact on price. Keep thinking about that word ratio, it's very important. I'm going to give you a classification of these, and we'll call this classification. And remember, E, which is elasticity, is equal to the ratio of the percentage change in quantity over the percentage change in price. And our classification says that it's inelastic if the absolute value of E is less than 1. These vertical bars on either side of the variable name E mean absolute value. Just drop the sign. We're just looking at the raw number. So what's absolute value mean? Absolute value just means whatever the sign of that, you compute that ratio and just drop the sign. The sign is always positive. Now, why do we do this? Well, economists can be sometimes a little bit lazy about doing simple arithmetic. Look at this ratio. What's the sign of that ratio? Well, since we've already established that demand curve is downward sloping, anytime price is going up, quantity is going down. Anytime price is going down, quantity is going up. We have that inverse relationship between price and quantity. So the sign of that ratio is always going to have a positive change in the numerator and a negative change in the denominator, or the other way around. So the sign of the total ratio is going to be negative every time. So instead of working with negative numbers, we just do absolute value. We say that it's inelastic if the absolute value is less than 1. Let's write out the full classification and then we'll spend some time thinking about it. We say it is elastic if the absolute value, if it's greater than 1, it's elastic. And we say it is unit elastic if the absolute value is exactly equal to 1. So what's the big deal about this 1? Everything seems to hinge about whether it's equal to 1, greater than 1, less than 1. The big deal here is that we're talking about a ratio. So the number 1 is always important in the ratio because it tells you whether the numerator or the denominator is stronger. If the absolute value is greater than 1, it means that the impact in the numerator, which would be change in quantity, is much bigger than the impact in the denominator, which is change in price. If it's less than 1, it means that the numerator effect, that is the change in quantity, is smaller than the denominator effect. Think about some arbitrary curve I might draw here. And again, we have price on the vertical axis, quantity on the horizontal axis. And think about that demand curve that we drew for gasoline. That demand for gasoline looked pretty steep. And what that meant was that we can have very big swings in price. That's the denominator. Very big swings in price will lead to hardly any change in quantity. Think about this example. Suppose this is the original price, and this is the original quantity. And suppose price went up dramatically. It doubled from $2 a gallon to $4 a gallon. Well, that would be a huge increase in the denominator, and the numerator would have what effect? Hardly any. People don't cut back very much on gasoline in this. So there's very little change in quantity for a wild change in price. That means the denominator can get really large compared to a small numerator. That would be a situation that looks like this. The ratio of the change in quantity over the change in price is less than 1. So let's get a little bit more concrete about this, and let's just draw 2 curves, and then I'll ask you a question. Okay? So let's go over here and put a couple axis systems up. And we have one, which we'll call market 1, has a demand that looks like this. And we have another one, which we'll call market 2, which has a demand that looks like this. And if I were to ask you to think which one of these would you call elastic or which would you call inelastic, well, hopefully you'll see that in fact this product is the one that's going to be inelastic, because you can have wild swings in price and hardly any change in quantity. And if we remember our formula for elasticity, it's equal to the percentage change in quantity divided by the percentage change in price. That ratio is going to be less than 1 when the curve is very steep. On the other hand, over here, you can have very little change in price could cause huge changes in quantity. You'd have just a little bitty drop in price from here to here would change quantity from here all the way down to here. So in that market, okay, the denominator can be small, but the numerator is going to be very big. And that's, of course, fits our story about elasticity, where the absolute value of that ratio is greater than 1.